Hello, everyone. This is Lance Liam, Professor of Biomedical Engineering at Penn State. Today, I'm going to share with you the ion transport across cardiomyocytes. So for cardiomyocytes, and then we have 4 different ions that are critical for cardiomyocyte function. The first one is the sodium ion. The second one is the potassium ion. The third one is the chloride, and the last one is the calcium ion. So let's call them 1, 2, 3, 4. So these 4 ions are very, very critical for cardiomyocytes function. For example, for the beating, the cardiomyocytes needed the calcium in order to show the spontaneously beating feature. And based on what we learned for the flux, the ion transport, the flux for any ion is equal to Zi, the native charge of the ion, times the permeability of the ion, and times FVm over RT times the ion concentration on one side times e to the power of Zi FVm over RT minus Ci on the other side over 1 minus e to the power of Zi FVm over RT. Okay? So here, if we define T equal to e to the power of FVm over RT. So then for each of them, for the sodium, this term will become just T. And then for this one, it will also become T. But then for the chloride, because the Zi is -1, so this one you will end up with 1 over T. And then for the calcium, because Zi is equal to 2, so you will get T squared, okay? For the calcium, you will get T squared. So based on the current within the cardiomyocytes membrane, what we can have is we will have the N1 plus N2 minus N3 plus 2N4. This is equal to 0, okay? So then we can plug in the flux expression for each of them into this equation. In this way, we can calculate the Vm across the cardiomyocytes membrane. That is the transmembrane potential, okay? So let's do that. And then based on what we observe, we can see each of the Ni will have the common term FVm over RT. So basically, this guy can be canceled because when you do the summary of them, that's equal to 0, okay? So then let's do it here. For the first one, what we will have is P1, because Z1 is 1, okay? So you only have P1. And then it will have P1 times 1 minus T, right? 1 minus T, and C1 naught T minus C1L, okay? And then the second one is the same, P2, 1 minus T, and then C2 naught T minus C2L, okay? And then the third one, be careful. Now the Zi is -1, so you should minus P3, and then be careful here. Now T become 1 over T, okay? So this one is 1 over T, okay? And then you got C3 naught 1 over T minus C3L, okay? And then the last one, be careful, this is 2, so the Zi is 2. And then originally it has a 2, so it should be plus 4 P4. And then you will have 1 minus T squared C4 naught T squared minus C4L, okay? And then this whole thing becomes 0, okay? So based on this, first thing you can do is here, you can both top and bottom time t, right? So basically this thing will become t minus 1, okay? And then this is time t, and then you will get minus t times C3L, okay? T times C3L. Second, for 1 minus t squared, for this, you can change it to 1 minus t times 1 plus t, okay? And then you can see for here, for both sides, you can cancel out 1 minus t, okay? Cancel out 1 minus t, okay? When you cancel this, be careful. This will change the, this will change the unit, because each of the other is 1 minus t, and this one is t minus 1, right? It's t minus 1. So basically, what you can do is you can change the sign a little bit, okay? So what you can do is you can change this thing to become positive, okay? To become positive. So in this way, yeah, so in this way, you simplified the equation, okay? You simplified the equation. So let's see for this, let's see if we make it right. Seems like we made a small mistake here. So when we say, so when we have this, right, should be, so that at the very beginning, you see this? This should be negative, right? At the very beginning, this should be negative. But then the Zi is also negative. So then negative, it will become positive, right? And then you have one of this to change the, the sign. So eventually this thing should be still negative. You got it? So you have 3 negative. The first negative is here. The second negative is from the Zi. And the last negative is from change the t minus 1 to become, to become 1 minus t. So you have 3 negatives, and then eventually this one is still negative. Okay? So now let's see, after simplification, what you got. So let's just delete this, and delete this, okay? And then delete this, okay? So what do you have eventually? You will have, let's see, what do you have? You will have, okay, this, and then you will have P3 times this, and then you have P4, 4P4 times 1 plus T, right? Yes, eventually you will have equation look like this, okay? So let's write down this. You will have P1 C1 naught T minus C1L plus P2 C2 naught T minus C2L, okay? Minus, be careful here, it should be minus P3 C3 naught minus no, they have another T, be careful. T C3L plus 4P4 1 plus T and C4 naught T squared minus C4L, okay? And this whole thing equal to 0, okay? So you can see this would be the final equation. This would be the final equation that we should have for solving, the T. Once you know T, because we define T as this, right? Once you solve for T, you can solve for Vm, okay? And then how do you solve for T? So you can put all the numbers in, and this equation will become quadratic equation. And based on this quadratic equation, you can solve for T. After T, you can solve for Vm, okay? So I hope these examples could help you in understanding the ion transport in cardiomyocytes. Thank you. Bye-bye.